Okay, so now we're going to change it up a little bit, and now we're going to have 3 chemicals. It's not going to be quite as complicated as what Alex was trying to get us to do, okay? But we're going to have 2 solutions. So here or 1 solution with 2 things in it. So write this down. If potassium iodide is added to a solution that is 0.001 molar in lead nitrate and 0.002 molar in silver nitrate, what precipitate will form first? Okay? So what we need to picture is that we've got a beaker, and what ions do we care about the most?
The insoluble.
The insoluble ones, which are not going to be what?
Nitrate.
Not going to be nitrate. And what else is it not going to be?
Potassium.
Potassium. Okay? So really what's going on in our beakers, we have some lead floating around, we've got some silver floating around, and then we're going to add little drops of potassium iodide, and will precipitation immediately happen? No, because we know from what we've been learning with KSP is that a little bit of lead iodide can be dissolved, a little bit of silver iodide can be dissolved. So at first, we're going to have ions floating around. At what point will precipitation start happening?
When it's saturated.
When it's too much, when we've got more than saturation, okay? And it's going to be, is the saturation point going to be the same for lead as it is for silver?
No.
No. Okay? In fact, let's kind of divide this up, and we're going to have to do 2 different analyses, okay? So we're going to have our lead, which when lead reacts with iodide, it will form lead iodide. So just like I always do, I'm going to start with a reaction, which is always the dissolving of my solid. So I've got lead iodide on one side, and I'm going to make a note that the KSP for lead iodide is 7.1 times 10 to the negative 9. And then on the other side, I'm going to make a note of my silver reaction. So silver is going to be in equilibrium with the silver ion and the iodide ion. Okay? And if we look that up, silver iodide has a KSP of 8.3 times 10 to the negative 17. So at first glance, which compound seems to be less soluble?
First.
The lead or the silver? Why the silver? It's a way smaller number, which means, I love how Jordan's bringing that in, if you have a really small K, that means it favors reactants. So this favors reactants, which is the solid, way more than this one does. Okay? All right, so let's figure it out. We've got some squaring over here and not squaring over here, so you can't always just compare 2 KSPs straight up, right? Because you have different math involved. All right, so here's what you do. It's actually not that hard. Am I diluting anything here? No. And what I should have said is that assume that the addition of Ki will not affect the volume. If it does affect the volume, I would have to tell you amounts, okay? So we're going to assume that it's not going to significantly affect the volume. So watch this, okay? Our KSP expression here is going to be lead to the first, iodide to the second. Our KSP expression here is going to be silver to the first, iodide to the first, and guess what? We already know the concentration of silver. It's 0.002. We also already know the concentration of lead. It's 0.001.
So,
And we know the KSP, 7.1 times 10 to the negative 9. Here the KSP is 8.3 times 10 to the negative 17. So guess what I'm going to get to solve for?
X.
Yes, and X is going to represent what? Iodide. This one is to the first. This one is to the second. And guess which one I'm going to pick?
That's where.
The one, once I get the X values, which one am I going to pick?
Would it not be 2x?
It's not 2x because, and that's a very, very good question. A lot of people try to do that, but the KSP expression is I negative, not 2I squared, just I.
From the actual chemical equation.
Exactly. On the previous problems we were, because where we were getting the iodine was the same place that we were getting the lead. So it was a 1-to-2 ratio. But here we're just, it's another source. So it's just X. Very good question. All right, so we're going to solve for each of these X's. Which answer are we going to pick? The one that's smallest. Okay, let's take a break. All right.